In communications and connected systems research at UCL, we cover many areas. These range from the circuits that are needed and used for communications to the subsystems that can make wireless and optical communications, wireless and wired communications, and even mathematical studies of traffic that flows in these networks. We believe that a wide and holistic approach to communication systems is important as these systems are getting more and more complicated. We collaborate with different industries, big projects with CERN. We have projects with the National Physics Laboratory. We have combined fundings across the work of the Institute that is close to £10 million a year. We have much internal collaborations that is within UCL.
Research within the Optical Networks Group is concerned with investigating what are the limits of both transmission capacity of optical fibers and the ways of intelligently using that capacity. The current debate in the world involves understanding just how much capacity can be carried over optical fibers. Are we approaching the fundamental limits of what can be transmitted over optical fibers? And fibers form networks. Therefore, is there going to be a capacity exhaust within the optical fiber infrastructure, which after all carries 99% of all digital data?
My research areas lie in the more general areas of networking and network and service management. Over the last 5 to 10 years, my interests lie in the information-centric networking, which is an emerging area of software-defined networks, and also the Green ICN project, which is another EU project.
Our major projects are in access networks, either optical access networks, how we can provide multi-gigabit fiber to the home networks to provide high bandwidth services, looking forward to 2020 and beyond. We've had a number of projects with Iccs in the UK and also collaborate widely across Europe. We are currently the lead of a 5th generation wireless project called FiWin 5G that has 10 industry and academic partners across Europe. This €3.9 million project connects researchers to undertake research projects that look at the next generation of fibre communication to support wireless access networks.
There is an EPSERC proposal which covers abstraction of the optical networking. And that's called Insight, and that's looking at how do we best abstract the physical layer so that the networking layer can use it best. I have collaborations with industry, such as Sienna, BT, so there's lots of interaction going on within the department on various aspects of optical communications.
The analysis of visual large content of image and video databases, there we work mostly with companies like BAFTA Research. It's a collaboration between myself and several other academics as well. For example, Cambridge University, University of Edinburgh and so on.
I have a PhD student who is working with the BBC at the moment, looking at how we can use optics to work in their production environment, but as they move to 4K or Ultra HD and even beyond that to 8K, where the amount of data that you get coming off these cameras is much, much greater than what we have today.
We currently are leading a research project. It's on compressive sensing and distributed compressive sensing for energy harvesting wireless sensor networks. So we are currently collaborating with EPFL in Europe, many American universities such as Princeton University, the Georgia Institute of Technology, Carnegie Mellon University, as well as Duke University more recently.
My research covers optical networks for computing. I see an important part of my work as being able to bridge the fields of optical communication and computer science, which so many researchers can do. I've also got important collaborations with INFI and also currently a major collaboration with Microsoft Research on data center networks.
Today, wireless communications systems are relatively energy inefficient. A big part of our research focuses on improving upon this energy inefficiency. So there's a lot of research on 5G communications, and we're looking at practical deployment aspects of these technologies. Our research is funded by Royal Academy of Engineering Research Fellowship. Our main collaborators in these areas are University of Edinburgh, Bell Labs in Dublin, and Manchester University.
I work with several industries such as Iccs, Techner. We won a few projects in recoverable antennas because sometimes the environment is hostile. Some standard antenna, just like what you usually see, may not applicable to for very efficient communications. Some of them is for military applications, some of them is for civilian applications.
We are working on a project where we're using the overhead lights in a room in order to transmit information. So this is called visible light communications, or Li-Fi. We are the first group in collaboration with Northumbria University, Bristol University, and other collaborators in the LCN to have developed a technology where we use organic LEDs and organic photodiodes.